You need it? No. I'm not using. Okay. For the recording, okay. Like there are more people coming in, let them come. Okay, guys, this is Spit's workshop, and I will be covering. I'll try to cover two products that we have bounties for, and please ask questions anytime. There's no AMA afterwards because I'm very hard limit on time, 30 minutes. So I won't spend a lot of time explaining what Pyth is. This will be more of a hands-on workshop, so you can see how to use it because it doesn't take more than 5 minutes to implement Pyth in your dApp. So Pyth and Oracle, we supply price data, we supply random numbers. Two things. So price data can be crypto assets, indexes, metals, redemption rates, meme coins also sometimes. Now we have some meme coins as well, and gold, silver, all commodities as well. And how is different from other Oracle? It's a pull-based Oracle. The difference between a push Oracle and a pull Oracle is in any push Oracle, what do you have? You go to blockchain and tell, bro, I need ETH USD price. You're like, okay, go and read the data on the state. That's how any blockchain or any Oracle work. But in this case, you have to pull the prices. So I'll explain you what do you mean by pull the prices. It's fine. Okay. So let's get directly started with the code so you don't have to understand everything and just do things. I'll do it in front of you in Remix. Okay? So this is the exact code that, yeah, I'll zoom it. Sorry. Okay, this is the exact code that you will see in the documentation. I will traverse the documentation in front of you so that when you are building, you can see what I did and you will remember with that. So if you go to documentation, and this is the landing page, you go to documentation. If you're building price feeds, I will recommend you to use the guides here and click here in EVM contracts. And we have a code, an example code. So if you see here, what things are there? There is one constructor in which you have to pass the Pyth contract. What's that Pyth contract? How can you get that? I will tell you afterwards. That's the first thing you need. Second thing you need, which prices do you want to read? Depends on application. If you want ETH USD price or BTC USD price, you need to know the ID of that you want to fetch. That's a second requirement. Third requirement, the last requirement is you have to pull the prices. So three things. One, you need the Pyth contract address of that chain. Second, you need the price feed ID that you want to fetch. And third, you have to pull the prices. That's all the things you need. So this is the main chunk or 3 lines of code that you will write in your code to fetch the price. This is an example method. If you see, we have the most important line which will make you eligible for bounty. A lot of people who tries to use Pyth, they do the same thing like other oracles. Go get price no older than or get price, and they say I'm getting an error, I'm not able to get the price. Reason is you have to update the price feeds by yourself. The reason is we can't give you prices every second on the chain. So whenever you need the prices, you update at that moment. So by using this, you can get prices every 400 milliseconds. That's how fast Pyth is. Yes? Yes. Yes. So exactly. So get price no older than means you enter the price feed ID and you have seconds. So if you say 60 seconds, so if the price that is updated on the chain is older than 60 seconds, it will give you stale price. Simple. And if you update the price, that means on that chain, that price feed is updated. So anybody can read the price for everyone. Simple as that. One way. That's all. So every price update causes like gas cost plus one way. And even this price update, if you see, there's an argument that you have to pass. This is a price update that you will fetch, the third requirement I told. You can send 100 prices together in one argument. And that's why we have one line, which is like get update fee, which will see how many prices that you're passing in this bytes and will tell you how much fees it will incur. So if you're sending one price update, one way. Sorry. So you do get update fee, you get the fee, you send that value fee and the price update, you fetch the price, you're good to go. That's all you have to do to get eligible for bounty. Forget about bounty, that's all you have to do to fetch the price. We have one question, yeah?
So if the fee is like too high, I can say to not get the...
Yeah, I'm pretty sure we have 540 price feeds. And in one time you can update up to 200 or 250. 250 way, I don't think anybody is high for anyone.
Second question, once you call that update price fee,
Yes.
what happens? Because like smart contract cannot call like off-chain, right?
No. So this price update will have the price. This update will verify the price that you brought is right or not. That's the first thing. And second, it will update the state on the chain. This will already have the price. But when you have to fetch from off-chain. That's the next part I will show. So when you fetch from off-chain, I have to make sure that you're not changing the price in between before sending in the contract. Yes. Yes. Till now, everybody is okay. 3 requirements. 1, we have to find the contract address. 2nd, which price feed ID that I have to fetch. 3rd, pull the prices. Now that's the trickier part where people don't realize that they have to do it in Pyth. So how to fetch the prices? So there are 3 ways to do it. Like we have our APIs, we have SDKs, or you can stream the prices. So if you see in this document on the left side, we have fetch price updates, a whole page. So you can directly fetch from a curl API, which will give you like a data like this. I'll show you in practice as well. A data which you will pass. Okay? Or you can stream the price, or I'll suggest use this SDK in your app because you will write a front-end code in every application you will build. Just write this SDK, call this. Hermes is the Web2 API which will help you to fetch this price update. You send the price IDs, get me price feeds up to you. This is get latest price updates, send these price IDs, you have the price updates. That's it. So I'll show you how it will work. So the same contract that I showed you, I'll run it in Remix. This is the same contract. Nothing has changed. I'm using ETHUSD. I'm hard-coded the price feed ID, but I don't need to. I am zooming out because it is difficult for me to do it like that. Okay. Let's compile this. Compile. Okay. Which chain do you think I should run it? Let me see how much I have. This is Sepolia, so I'll run it on Sepolia. Okay. Now I have to pass Pyth contract. This address, how will you fetch it? If you see in our documentation, we have a reference material, we have contract addresses. This is here. You go to EVM, and these are all the chains that we support on mainnet, and these are all the chains that we support on testnet. So I believe we cover everything that you want, especially in EVM space. You won't have that complaint. So let's find Sepolia here. Yeah, we have so many Sepolias now. Yeah, here it is. So I just copy this and pass it in my remix here because I need to deploy it along the constructor asks this. So I pass this Pyth contract address, deploy it, transact not payable. Sorry, what's... I think I'm doing a wrong one. I think this is the... Yes. Oh, okay, I've selected the wrong one. Yes. Yes. So I'll add it here. I don't know, something wrong. My MetaMask is not taking the Sepolia one. So you just pass that contract address and you deploy it. Now, after that, you will go to Hermes that via either API or SDK, up to you. And we have a Swagger file also, so it will look something like this. So, for example, you want ETH USD price, and I'm passing it so that you can see. When you execute it, you will get this bunch of binary data. This is the price update that you will have to pass in that method that I show you, example method. This is the thing, main thing. Exactly, this is the call data. Just remember, because in Solidity, every string is represented by 0x, just add 0x here. We have not added 0x here because we support Starknet, Solana, everything. So it will create a lot of confusion. So just add 0x, and there will be no errors after that. Just pass this and run your contract. And don't forget, that method has to be payable, so you have to pass some fees. So that's how normal price feed work. Wow, I'm fast. So we have a lot of time. I'm being very fast. So let's 5 minutes. We'll talk about price feed if you have any questions, and then I'll move to the next bounty. Yeah, this. You will get the price in this variable, and you want to use up to you. Yeah. So it is already updated here. The option data you passed, that binary data I showed everyone, you passed here. You update the data here. The Pyth contract on-chain is already updated. Now you just have to read it by here. So off-chain Oracle is not fetching directly. You are fetching from off-chain Oracle, from Hermes that I showed. So I'll try to run it on Remix.
Yeah, I think my question is like, because like the smart contract on chain cannot call the off chain oracle, right? So how can it pull data from the off chain oracle?
So you are pulling the data from price update. How we are verifying the data, I believe that you're asking?
Yeah, like how to
Yes.
verify it
So we
with the
send-
off chain oracle.
So it's not, okay, the off-chain Oracle, we send Merkle proofs of every price via wormhole. You don't have to worry about it. We verify the prices on the back end via wormhole.
Yeah, I would just wonder how that works.
It's just wormhole is a bridge. It's a cross-chain bridge.
Oh, you just send like a message.
Yeah, we send the proofs of prices that you guys are not changing the price between the way. That's how it works. I can explain the architecture afterwards.
Okay. Yeah.
Okay. Okay, let's go to the, if this is clear, I believe, to everyone. Okay. So 3 things. You need the contract addresses. You will find the contract addresses from here. Second, you need the price feed IDs. All the price feed IDs are here. In this page, this is a price feed catalog ID. It will look something like this. So you can find everything. And third, you need to pull prices. How you can pull prices, the whole guide is written here. 3 things, that's all. Now, coming to the random number generator, the product we have called Pyth Entropy. Using that, you can generate random numbers. And how that works, it's very straightforward. For example, you need a random number. You come to Pyth and say, bro, I need a random number. And what I will say, it's like a commit reveal protocol. What's a commit reveal protocol? I'll say you submit a random number by yourself. Could be anything. And I will submit a random number by myself and will submit the hash of the random number on the chain and will commit it. Once anything is committed on blockchain, you cannot change it. Agree? In the next block, I will ask you, now show me your random number. And I will also show my random number. And we will verify each of the random numbers using that hash. Once that is true, the final random number will be hash of both. That's how it works in the backend. But what you have to do is the contract will look something like this. Simple, 2 methods, that's all. You have to call only one method. So you want to request random number. What I told you, you have to submit one random number. It could be anything, you submit that. You submit your random number in the argument. Its default provider use that. The provider is the one who will send the random number to you. And this is the thing you have to call, request with callback. When you request with callback, get the fees just like price feed that we did. The entropy provider address, it's in the guide I'll show you, and your random number, it will send back a sequence number that you store up with you. And you have to implement this method in your contract, which will be called by the provider. Like a callback we have in ERC 1155-721s, a callback method. So our provider will call your contract by this method. So you have to implement this method, entropy with callback. We will, like Pyth provider will call that with the random number, final random number. That's it. So you have to just do this. And in the next block, or the reveal time for every chain is different, we will send you the random number. For every testnet, we'll send you in the next block only. That's it. You have to call this, we'll call that. And you can generate random number with any JavaScript library like crypto, Web3, Ether, even VM. No, VM doesn't have random number now, but every library have that. Any questions? Yep.
Yeah, just about like the bytecode that we can put inside the entropy callbacks. Are we limited? Like, I mean, it will be Pyth that's going to call our callback, right?
Yeah.
So we just in terms of bytecodes that could be executed, we are limited. I mean, or should we? I mean, about the design, should we store the randomness and then do the process we need to with this number afterwards, or we can do it directly inside the callback function?
You have to do it in the callback function. And the limit for that callback function is 500K gas limit. Okay. Because we will call that method, so we are paying the fees for that.
Okay.
So we have to put a limit. So I would always suggest, this is, because since this method will be called, in the same transaction you want to implement your logic. Because if that transaction happens, people will know what the random number is in the next transaction. So I will implement a callback logic here, or your random number, that how you want to use. Any other questions? I'm going very fast. I know that. Because last time, every time I've done this workshop, I go very slow. A lot of questions come, and I skip the entropy part. So we have time. You can ask questions. If you want me to repeat anything slowly, I can do that. Yes? No, it's not like price feed. This is completely different. We are not getting the random numbers from the same Oracle service that we have. The flow is also not same. No, no. It's completely different. Don't confuse with price feeds. Price feed is pulling the data. This is like, I need random number, just send me that. No, Oracle doesn't post the data. You pull the data. That's the difference between push and pull Oracle. When I showed that you have to go fetch price updates like this, remember? When you call this API, the data you see here, which is highlighted, is the update data, the call data, and the price will look something like this. But when you submit this here, I'm using my left hand, sorry. That highlighted binary data, call data, you have to submit here. It already contains the price. But you have to verify the price if you're using it on chain, and that's where this happens. So you have to pull the price. That's a catch. If you see in the bounties that I have mentioned, I've mentioned many times, if you don't pull the prices, you won't be eligible for bounty. You have to pull the price. But if you are building something and you want to integrate many oracles together, and the interface would be different for every oracle, you can run a bot which will keep updating the price. We also have that bot. It's another document. I'll share that. So you can also do that. So I'll check each and every code how you are updating the price. So you have to update the price. This is the crucial part. You have to fetch the price, update the price, consume the price. 3 steps. And 3 things that require the contract address on any chain. That, like, if you're deploying on Blast, you search from Blast, what's the address, put there. Which feed do you want? You fetch the update data for that, consume it. It's storing and verifying. 2 things are happening in the backend when you run this. First, it verifies that, okay, you fetch the data from an off-chain service. The Ethereum price is $3,500. You change to $3,700. And you tell Pyth, update the price. It is wrong. So here, that update checks that, have you changed the price or not? How? It's like every time you fetch the price from off-chain, we send a Merkle proof of that price on-chain, not the whole thing. It's just a proof. And we check computing the Merkle proof here and here. If they're same, that means you have not changed anything. That's clear?
So it's like when we call that get the price.
Yes.
So the user will get the price from one pass.
Yes.
And then the provider will submit the Merkle tree
Yes,
through another
it's already
pass.
submitted all the time. So
Okay, gotcha. So in the contract, it will verify,
Yes.
like compare those two. Okay.
Exactly. So it will first verify and update the state. So you're just reading the state here. Simple. And you can combine 150 or 170 prices together in one update. So you don't have to call transaction again and again. So that's how you can fix it.
Have multiple price feed IDs?
Yes, like this. If you see in this, in the same API, I can add many. Like right now, it's replicating the same one, but you can add many. If you execute, it will give you one data, a bit longer, of course, but you pass this only. So right now, if you see, I have passed how many? 5. And if I go here, so if I pass that 5 price feed data, the fees here will be 5 now.
But does that rely on the execution of this transaction and the Merkle proof are submitted in the same, have to be in the same like block?
No?
So what if like this logic is executed at block 1, but the Merkle proof
So Merkle proof is not submitted like that. When you update the price feeds, our contract will fetch it from the wormhole. So don't worry about the Merkle proof from your end. We will verify it. We fetch it Merkle proof from the wormhole at that point of time. We verify it. So everything happens in one transaction.
So with the VRFs, is it with REN? Yeah. So with VRFs, why do you need callback to specify upon like
So in the first transaction that you send, when you request for callback and you send your own random number, we commit it. If we can't send this random number same transaction unless you commit your random number. Like, what if you change the random number? So that's why callback happens in the next transaction and we send you the random number. That's why the callback mechanism is there.
So in the next transaction, you'll call my
Yes.
function in my smart contract that
Exactly.
I've specified in the callback?
Yes. So it has to be the same interface, like reveal with callback. I'll open it again. Yes, entropy callback. So our provider will call this method on your contract and with the random number, and you will implement logic inside this method only.
Only to work with that random number.
Yeah, if you want to use random number, it's coming in the argument so that you can use in the same method.
Well, I can just store it in the storage, right?
Okay, then
Right?
yes.
Okay.
If you store it and then call another method in the same transaction, then it's fine. But by the next time, everybody can see the random number. So what's the use of that random?
Oh, yeah. It has to be used immediately in the scope,
Exactly.
right? Okay.
Any other questions? We have time. I can okay, I'll show you some other things so that it's easier for you when you're building it. In the documentation, if you see, for the entropy, we are only available on these chains. But for price fees, I showed we had a big list. These are all the main nets. And we have test nets as well. I'm pretty sure you'll be using test nets. These are all the test nets. And this is the provider address that you will send it to the contract.
Wait, that's for randomness?
Yes, that's for
Okay.
randomness. I'm talking about randomness right now. And the fees varies for like, these are the fees. So you don't have to copy the fees from here. You will use the on-chain method to fetch the fees, which is written already here. Get fee. So the fees for price feeds and the fees for entropy is not same. For price feeds, it's one way per update. For entropy, it changes as per the chain. So you can generate thousands of random numbers in one transaction. Can you guess how?
Well, like that array of like the same. You said you asked for randomness, right?
Yeah, randomness. Like I gave you one random number. You can generate 1,000 random numbers out of that.
Oh, they're like hashing?
Yeah. You
Wow.
can hash it. You can use a C to hash it or anything. So that's right. So if you see, we have something like reference material, best practices. So you can generate multiple random numbers in single transaction. So with a callback, you can just encode pack, hash it, and have multiple random numbers with one transaction. So you don't have to pay for 10 or thousands of random numbers. Just hash it with different seeds. That's what ABI encode pack with Kekak 256 does. So I'll recommend everyone to use the guides. They are short, they're crisp, and they contains everything.
How up to date are they?
I updated it. Don't worry.
Today?
So we have not changed anything in past few months.
Okay.
But I keep updated some reference materials and all the contract addresses are updated. I'm just putting an update. I'm pretty sure it will go by like in 2 hours. But if you go to price feed IDs page, these are the price feed IDs for prices. Even though you're using mainnet or testnet, don't get confused by EVM beta or stable. Don't look at this. These are all the price feed IDs you need for Litecoin. I don't know why it came to my mind.
Yeah, so the price feed ID always stays the same across
yes,
testnets and
exactly.
every chain?
Every chain, irrespective of EVM, non-EVM, Solana, or whatever you want, price feed IDs will remain unchanged.
Okay. So then, like when I switch chains, I only look to switch the address of the
Yes.
oracle.
Exactly.
Okay.
And the price update that you fetch from home is chain agnostic, doesn't care about chain. So you just have to change the constructor Pyth contract address. That's all. So when you switch the chains, you have to change this. That's all. I have 30 more seconds, and I've spoken a lot. For price feeds, right now, think of any use case where you need a lot of prices together or very frequent prices. Trading, like almost every perps out there use us. Or DeFi applications are switching to Pyth because we can send you data every 400 milliseconds. And for any random number, gaming, lottery, anything like that where you need random numbers, you can use it. Exactly. It's cheap. It's all permissionless. You don't have to contact me, dude, I need random numbers. Yeah. Yeah, it's doable. So you
Sorry.
can make this oracle as a push. Just answering the last question.
Sorry, can we please go to their booth to
Okay, yeah.
continue this
I'll answer
conversation?
that.
We have
Thank
to
you, guys.
continue with the next talk. Thank you so much.